Want to learn engineering and science? Well, you've tuned in to the right channel. Hit subscribe and press the bell icon and never miss an update from us. Hey guys, what's up? This is your friend and tutor Manas, and I'm back with a brand new lecture series on auxiliary planes, which is an extremely important topic in engineering drawing or engineering graphics. Now, this topic was requested to me by a lot of my subscribers and viewers, so the wait is finally over as we'll start right now. But before we begin, I expect all of you to watch this video right till the end, because once you have a firm grasp on this method, I'm sure then you're going to be able to solve all the problems based on projection of lines, planes and solids. So let's kick off today's session with one simple question. Why are we studying auxiliary planes? What's so special? Well, to answer that, let me give you a demonstration. So here we're going to be considering an object, a 3D object, and we'll try to look at this object from three different ways: from the front, from the top, and from the left hand side. Okay, so that we can have the front view in this vertical plane, we can have the top view in this horizontal plane, and we can have the left hand side view in this what you know as a profile plane. So what's so special about these three views? So when you try to look at this object from the front, these three rectangles, or shall I say the true shape of these three rectangles, are pretty much visible in this front view. Okay, what about this? The true shape of this portion is also visible in the front view. All right, and that's the idea behind having an orthographic projection, that it should be able to provide the true shape and size of the object from the front, top and side. Now guys, if you watch carefully, when you try to look at this object from the top, this portion is clearly visible here. Okay, its true shape and size is visible. This portion, this over here, that is also visible in the top view. What about this portion? This is sort of a slant portion. Okay, this rectangle over here. So the true shape of this rectangle is not visible. Rather, this is the apparent shape. Okay, if I say that this, let me number this by 1, 2, and let's say this point is referred by 3, and let's say this is 4. This over here represents the apparent shape of 1, 2, 3, 4. All right, and when you look at this from the side, this also is the apparent shape of 1, 2, 3, 4, or rectangle 1, 2, 3, 4. That means orthographic projection right now is a bit unfair towards this profile of the entire object. Okay, because all the other profiles have been represented by their true shape and sizes. Now these three rectangles have been represented by their true shape and sizes in the front view, and as far as this rectangle is concerned, its true shape and size can be seen in the top view. As far as this rectangle is concerned, its true shape and size can be seen in the side view. But there is a problem with this rectangle over here, which is slightly inclined. Okay, its true shape and size, it's not visible in the front view or the top view or the side view. So some sort of a solution has to be worked out. Okay, so here is the solution. And if you want to have the true shape of this particular profile of the object, you have got to look at this object in a sort of perpendicular way with respect to this plane over here, this plane 1, 2, 3, 4, sort of from here. Okay, and the view that you're going to have when you look at this object from here is what you call an auxiliary view, which is going to be obtained on a plane which is known as auxiliary plane. Let me show you how that looks. Here it is. That's what you call an auxiliary view. Let me go ahead and write this: auxiliary view. Okay, and to be very specific guys, this auxiliary view is an auxiliary top view in fact, because the plane on which this is going to be obtained is an auxiliary inclined plane. Now again, you guys might be confused as to what an auxiliary inclined plane is. Now let me go ahead and tell you that auxiliary planes are basically of two types. One is auxiliary inclined plane, while the other one is what you call as auxiliary vertical plane. When you speak of an auxiliary inclined plane, it is perpendicular to the vertical plane and it is inclined at a certain angle to the horizontal plane. Okay, and the sort of view that you obtain over here is what you call the auxiliary top view. When you speak of an auxiliary vertical plane, this particular plane is perpendicular to HP. Okay, and it is inclined to VP, and the view that you're going to obtain in this particular plane, that is AVP, is what you call the auxiliary front view. That's it. So there are basically two types of auxiliary planes: AIP, AVP. AIP is where we have the auxiliary top view, and AVP is where we have the auxiliary front view. This red color view that we are obtaining is an auxiliary top view. Auxiliary top view is obtained in an auxiliary inclined plane. Okay, so over here we will be having an auxiliary inclined plane. So that was all about projections. This is front view. Okay, let me write this. This is top view. Over here we have the left hand side view, and this over here is the auxiliary top view obtained in what you call an auxiliary inclined plane. Okay, now front view is obtained in a vertical plane, you know that very well. Top view is obtained in what you call the horizontal plane, and a side view is obtained in a profile plane. So when you speak of an auxiliary top view, it is obtained in an auxiliary inclined plane. So that's it. So that's the entire idea behind having an auxiliary inclined plane, because sometimes you're going to see that the true shape and size of any particular profile of an object will not be visible, neither in the front view, top view, or the side view. Okay, and that's where you're going to have to use this auxiliary plane. All right, now let's understand how to do this on a drawing sheet or on plain sheet of paper. And for that, here we go. So over here we have the front view. Okay, that's the front view. When we look at this object from over here, that's the front view. When you look at this object from the top, this is what you're gonna have. That's the top view. And when you look at this object from the side, you're gonna be getting the side view. Okay, it's gonna look something like this. There you go, and that's it. That's the side view. This L shape is something that you're gonna obtain. But when you speak of this, okay, this rectangle over here, it appears as a line from the front. That's not visible, or its true shape is not visible. How to obtain that true shape in a two-dimensional platform, in a two-dimensional atmosphere? That is something that I'm going to be explaining you right now. Okay, 1 2 3 4. All right, 1 2 3, and that's 4. So when you try to look at this from the front, okay, that is the projector line, and 1 dash comma 2 dash, and this is going to be 3 dash comma 4 dash. Okay, now in order to have the true shape of this particular rectangle over here, this is the apparent shape. Okay, we have to look at this from over here, something of this sort. Now I'm going to be fitting an auxiliary plane, and to be very specific, this plane appears as a line. Okay, there is a plane over here. Let me show you. There is a plane over here, something of this sort. Okay, which is known as auxiliary inclined plane. When you look at that object, or when you look at that plane from the front, only this line will be visible. That's why we are drawing a line over here. This is what you call an auxiliary inclined plane, and the view that you're going to be obtaining in this particular plane is what you call the auxiliary top view. All right, so we'll be having an auxiliary top view over here. For that, what needs to be done is, if you watch carefully, these are the projector lines making an angle of 90 degree with this surface. Exactly, that's exactly what needs to be done. So you need to keep your mini drafter, one scale of your mini drafter aligned along this line, tighten the screw, and the other scale will automatically give you this 90 degree lines, right? That's very easy. So what we are essentially doing is, we are trying to prepare or construct the auxiliary top view with the help of this front view. So remember this, guys, when you try to create an auxiliary top view, you have to take this as the reference line, XY as the reference line. So right now we are working with x1 y1. So before that x1 y1, we have xy as the reference line. Okay, so we are preparing the auxiliary top view over here. Okay, so the previous top view is this one. So we have to take this 1 2 3 4 as the reference. So keep one leg of your compass here at x, or the reference line, other leg at 1, and with that much amount as the radius, and then with this guy, this guy as the center, you need to put an arc. This essentially is what you call point 1. Okay, do the same drill again. Keep one leg of your compass here, other leg at 2, with that much amount as the radius. Okay, then with this again as the center, you need to put an arc yet again. This is going to give you point 2. Repeat the same stuff. Over here you're going to be getting point 3 and point 4. So keep one leg of your compass here, other leg at 4, and with that much amount as the radius, and then with this as the center, put an arc, and that's precisely point 4. And repeat the same stuff. Keep one leg over here, other leg at 3, keep with that much amount as the radius, and with this guy as the center, put an arc here again. That's going to be point 3. When you join all these points, you have the true shape, right? So that's how That's why auxiliary planes are so essential in obtaining the true shape of any profile which somehow got missed in the front, top or side views. Now this method is going to be extremely important because in the upcoming lectures, I'm going to be telling you how to find the true length of any given line with the help of this method. I'll be telling you how to draw the projection of a plane when its surface is inclined and one of its edges is also inclined. I'm going to be discussing the projection of solid whose axis is inclined with the help of this auxiliary plane method. So this entire week, it's going to be all about auxiliary planes. So guys, that was all from my side for today. If you've got any doubt or query, do write them down in the comment section below. I'll be very happy to answer them. And if you believe that this video tutorial has added value to your knowledge of engineering drawing or engineering graphics, then do share and like this video, subscribe to this channel, and also press the bell icon so that whenever I upload a new video, you get a notification. I'm going to be back again with some more videos on auxiliary planes, and preferably I'll be doing a video on projection of planes. Okay, how to incline the surface, how to incline the edge, and something of that sort with the help of auxiliary planes. So bye bye and take care.